I'm assuming at this point that you have finished the engage portion and you are now at the learning portion of your 5.2.A HyperDoc wave speed. The A just means that we're only learning about one specific thing, which is just wave speed. We will be learning about some other wave behaviors later in the week, but I just wanted to give you one thing specifically for today. All right, so to figure out speed, we already have an equation. It is distance divided by time. We've been using this equation since the beginning of the year. So for example, if we have a dog that runs 500 meters in 45 seconds, then what is the velocity of the dog? You would just use this equation, v equals d over t, plug in your numbers, 500 meters for distance over time of 45 seconds is going to give you a velocity of 11.11 meters per second. That's really fast, okay? So this equation still works, but waves are really fast, and to be more precise, to study waves, we can actually use the components of waves to calculate their speed. So instead of trying to set up a speed trap, like having a line on the ground and then a wall and then like shooting a laser between those, it just wouldn't work because waves are so fast. So what we can do is use wavelength and period or wavelength and frequency. Now let's think about why. Wavelength is a distance, right? It is a distance. It is the distance between on a wave. So let's say this is a wave. It could be the distance between this point and this point, between A and B. It could be the distance between this point and this point. We'll call that C and D. Or from trough to trough. There's our trough. And we'll call that E to F, right? So these are one full wavelength apart. Crest to crest is probably the easiest one to pick out, but you could use trough to trough or center point to center point. Just depends on what your preference is. My preference is crest to crest because that's the easiest to pick out. So A to B, right? This is a distance. The wavelength is a distance. So that is the same thing as your original distance in the original speed equation. Period, which we denote with a capital T, is a time. It is a period of time. Basically what it's saying is how long does it take for A to get to B? Because the wave is moving to the right, and so the amount of time that it takes one crest to reach the position of another crest is a period. How long does it take the wave to do one wiggle? Because it's just wiggling once from A to E to B. Yeah. Okay, so it really is the same thing as the original equation. It's just specific for waves. Okay, and this is the basic form. But remember, frequency is equal to 1 over t. So since we have 1 over t here, we can also replace t with like 1 over t with f. Like for example, if I were to break this equation down, let me do that real quick. So I'm going to rewrite this equation as v is equal to lambda times 1 over t. If we remember that frequency is equal to 1 over t, I can take this, replace it with this, and that will give you this equation, which is v is equal to frequency times lambda, or wavelength. Okay, so they are exactly the same thing. I was just substituting period with frequency because you can do that. It doesn't really make a difference either way. You can use whichever one, and realistically you should use both. So let's look at how to use both of these equations because they are both useful in different situations. First example problem here. What is the speed? Let me get a nice color going on here. What is the speed of a wave with 0.5 meter wavelength and a period of 4 seconds? Okay, so first things first, I can see that the speed is unknown, velocity is unknown. We have a wavelength given to us of 0.5 meters, and we have a period of 4 seconds. Okay, so step one in our problem solving procedure, which you should always be using in physics because in physics, organization is everything. Step one is to list our variables. Normally you would have to draw a picture as well, but the picture in this case doesn't really help us. Like it would literally just look like this. It's not super useful right now. So for this context, you're not gonna have to draw any pictures, just label your components. So things that we picked out of the problem, velocity is our unknown, that's what we're solving for. Wavelength is equal to 0.5 meters, and our time period is 4 seconds. Okay, number two, step two, we need to write out our equations. We have two different equations right now. We have velocity is equal to lambda, or sorry, wavelength over period, or we have, or we have velocity is equal to frequency times wavelength. So now comes a decision. Which one should you use? Well, let's make that decision based on what we have. In our case, we have V, lambda, and T. This equation down here has V and lambda, but it doesn't have T, it has F. So that equation is not going to work. We cannot use that equation because we don't have the pieces for it. The first equation, however, we have V, we have lambda, and we have T, which matches what we have over here. So I'm going to say let's use this equation. All right. So final step now. Plug and chug, just plug in your numbers and solve the problem. Okay, so V is unknown, so we have nothing to plug in for it. It doesn't change. Lambda, wavelength, is 0.5 meters. And T is 4 seconds. Plug that into a calculator. 0.5 divided by 4 is equal to 0.125 meters per second. Woohoo! All right, let's look at another one now. All right, we have a sound wave with a speed of 343 meters per second and a frequency of 432 hertz. What is the wavelength? All right, so let's break this down. We have a velocity of of 343 meters per second, a frequency of 432 hertz, and a wavelength that is unknown. All right. So step one, let's list our variables. All right. Velocity is 343 meters per second. Frequency is 432 Hz, hertz. And lambda, our wavelength, is unknown. That's what we are solving for. Step two, pick our equation. Our first equation is V is equal to wavelength divided by T, or or we have V is equal to frequency times wavelength. Okay, which one should we choose? Again, we need to choose which equation to use based on the variables that we already have. In this case, we have a V, an F, and a lambda. Velocity, frequency, wavelength. Okay? So the first equation has velocity. That's good. It has wavelength. That's good. But it has period. We don't have period, so we cannot use this equation. All right, let's look at the second one. We have velocity, we have frequency, and we have wavelength. So this one works out, so let's go with this one. All right, step three. Plug in our numbers and solve, or plug and chug if you will. V, we have V, it's 343 meters per second. Frequency is 432 Hz, hertz. And we're going to multiply that by lambda, multiply that by wavelength. We don't have wavelength, so we had to leave it blank. Okay, so, wavelength is over here, but it has a number on the same side of the equation as it. We need to get lambda, or wavelength, by itself. How do we do that? Currently, it's being multiplied. We need to do the inverse operation. The opposite of multiplication is division. So we're going to divide both sides by 432 hertz. This one goes away, that one goes away, leaving lambda by itself. And then 343 divided by 432. Oh, I can't do that in my head. 343 divided by 432. Okay, that gives us 0.79. 0.79. And remember, wavelength is measured in meters. Okay, awesome. All right, one more of these bad boys. What is the speed of a wave? Let's do blue this time. What is the speed of a wave that has a frequency of 525 and a wavelength of 32? Okay, so according to this, making our list, velocity is unknown, frequency is 525 hertz, and wavelength is 32 centimeters. Oh, that's weird. Centimeters. I just got done saying that wavelength is supposed to be in meters. Okay. Well, I must have thrown a wrench at myself here. All right, so we need to convert this to meters. If you remember, the metric scale goes King Henry died unexpectedly drinking chocolate milk. Okay, so we're at cm. C is here, and we need to get to just regular m, which is here, which is 2 spots to the left. So we need to move our decimal 2 spots to the left. All right, so get rid of this basically. So we have 0.32 meters. We just converted centimeters to meters. You could also do this on the internet, though you should be able to do it this way because that was really simple. All right, so let's go to step 2. Look at our equations. All right, first equation is V is equal to wavelength divided by period. And then we have a second one, or we have velocity is equal to frequency times wavelength. All right, well, to pick, we need to find the equation that has V, F, and lambda. The first one has V and lambda, but it does not have frequency. It has period, so we cannot use this. The second equation, we have V, we have lambda, and we have F. So we're going to use this one. Awesome. All right, so final piece here, step 3. Plug in our numbers and solve our equation. V is unknown, so we can't replace it. F is 525 hertz times lambda, which is 0.32 meters. All right, I can't do that in my head. 525 times 0.32 gives you a V of 168 meters per second. And there we go.